Ladies and gentlemen, welcome to video number 16 in a series of video lectures which are companions to the book The Fivefold Sun, which was filed at the Bibliothèque Nationale de France in late 2017. We are now today November 22nd in 2018, about a year later. Today we introduce the contents of part 3 of this book, which deals with the geometrical kinematic of the solar ball from minimum activity epoch to maximum activity epoch, and tries to describe and maybe to interpret the transformations of the Sun in this cyclical interval. This is a big part of the entire book, and it is the entirety of its part 3, encompassing 450 pages that will be summed up here today in a few minutes in this video. The book indeed consists of 6 parts in all, from 1 to 6, and we are now in part 3, the geometrical kinematic of the Sun, namely of the solar ball. In video 16, we start by summing up the suggested cycle kinematic as was found in part 1 and shown in this series in video 2 to video 6. First, the cycle kinematic for the Sun, as suggested in part 1, is based on a series of laps of the equator versus the solar poles during the differential rotation of the Sun over about 11 years. The number of laps accumulated over the cycle reached 60 at the end of the cycle. It is important, however, to realize that in the kinematic that is suggested here, the start of this cycle, of this lap accumulation, is at maximum epoch. At solar maximum, with 60 accumulated laps over 144 rigid rotations in all, there is a reset to 0 lap by unwinding of the magnetic field lines that were wound up during the cycle. And this unwinding is triggered by the reversal of the solar poles. The observed magnetic flip of the solar poles at maximum epoch corresponds to a detailed phenomenology that has been observed for many decades in detail, and is as follows. There are about 2 years of, as an average, of havoc at the Sun, during which the poles will reverse once or 3 times as a characteristic behavior. Havoc means that there is an apparent equatorial dipole, whereas at minimum the dipole is axial, but it is rotating in longitude. And in fact, it is only an apparent equatorial dipole because, in fact, there is a multipole that is inferred for the magnetic structure of the Sun during maximum epoch. A multipole means that there are more than 2 poles. The order of the multipole may be 3 or is likely more than 3 and could be 5 or 7, as found from a meta-analysis during this project, the Fivefold Sun, of the literature in which such were the numbers, the order integers that were found in the literature for this multipole. Of course, the order 3 is the largest order which can be represented in only 3 dimensions, with 8 poles. It's called an octopole. But for order 5 with 32 poles, or order 7 with as many as 128 poles, as suggested by a few authors, in the Sun at solar maximum, we need 5 dimensions or 7 dimensions. Moreover, there is a phenomenon of ejection of masses, in the case of coronal mass ejections, CMEs, in the entire solar ball from 0 degree to 90 degree during this phase of the cycle. They are large in width, from 30 degree to 60 degree as a characteristic range for the width. And there are also ejections of magnetic flux in great quantities. So you see that 30 degrees or 60 degrees are really considerable compared to the entire solar volume, and would correspond to angles that are supported by entire magnetic regions of very large scale, such as the giant magnetic scales that we discussed in the video dedicated to the longitudinal phenomenology of the Sun. The interpretation of this phenomenon of the polar reversal in the literature, if we follow Snodgrass 2000, this author suggests that what he sees in detailed observations of this phenomenon at the poles is that each pole is not flipped around, but is becoming surrounded by new polarity regions until it vanishes entirely into the new polarity in the central location of the pole itself. So the interpretation that is accepted in the literature is that there is no direct migration from pole to pole. It is a complex, probably not a random, but apparently a complex and unpredictable kinematic process. We shall show this now in a 3D model. If we now look at a ball again, a sphere like the solar ball with a north pole and a south pole, and try to describe how the pole moves, as for example described in Lifshitz and Obritko's report in the literature in this century, you see that the pole would move, for example, to this lower latitude position, then change in longitude, again change in longitude, maybe it would come back to a higher latitude, and then after meandering in a somewhat labyrinthic way like this, the pole would end up in the opposite hemisphere and finally in the South Pole. Based on this known phenomenology, in the Fivefold project were asked the following questions. If there is no simple rotation from north to south for the migration of the North Pole to the South Pole and conversely, is it possible that the migration happens in the form of a complex sequence of translations and or permutations among large-scale magnetic regions in the Sun? If this was the case, the next question is, would such permutations or translations require a relaxation of the 12-ball frustration in the case of icosahedral symmetry in this ball? As you remember, frustration means that all of the outer balls are mutually tangential 2 by 2, and all of them are tangential to a central cavity, which in the case of the Sun would be the solar energy generating core. If a relaxation is necessary, is it also necessary to have enough free rooms between any of the outer balls surrounding a central cavity to make room for the permutations or for the translations? If such room is necessary, is it conceivable that the ejection of magnetic flux during a solar maximum epoch, and almost only during this epoch in the cycle of the Sun, is the cause of or a factor that makes free room possible? These are the questions that we are going to try to answer. In observations of the Sun, there is a possible change in the radial proportion along the solar radius, which define the depth of the differential rotation zone, which, as we saw in part 2 of the Fivefold Sun as a book, corresponds to a few percent of the radius of the Sun inward of the fully convective zone's border. So this depth of the differential rotation zone was determined to lie at 0.65 radius fraction at the minimum epoch in the basic arrangement, which is postulated here for the Sun at minimum epoch. Now, observations perhaps indicate that at maximum epoch it is at a slightly different location, which would be 0.67 radius fraction instead of 0.65. This, as you can read in this page excerpted from the book, is based on a few number of observations, only and from a couple of authors, and that's all we have, because before the first measurement, which is cited here in 1988, there were not any instruments that could determine such measures. So 0.67 is a possible but very preliminary value for the depth of the differential rotation zone at maximum epoch. You will see now that, in fact, this small difference has large implications. We now investigate the theoretical case of a relaxed 12-ball arrangement, allowing for permutations among balls that are now free to move, if this is a relevant arrangement for the solar ball at sunspot maximum epoch. We are back now to our 3D model with 12 outer balls tangential to a interior central cavity, which would be the basic arrangement in the solar ball during minimum epoch. And we see that a polar ball, which is encased in a cone, which we described in a previous video, we can extract this polar ball, or we can in fact extract any other ball, and then we will have the opportunity to move one other ball and to start a sequence of translations in this arrangement. So this is a case in which we have in a circumscribing sphere exactly 12 slots that are in an icosahedral arrangement, in which we have only 11 balls, and we can move the balls, because if I move one of these balls, there is room for this ball to translate, for instance, now in the polar position, and then I will be able to translate another ball to another position. If we now want to think about alternatives to this case, we have to consider the case with less than 11 balls, but it is not necessary, or the case for more than 12 balls. The limit case with 13 slots at the surface of the cavity for an arrangement of equal spheres about a central cavity at maximum epoch for the Sun corresponds indeed to a radial fraction of 0.67 radius fraction for the boundary, the inward boundary of differential rotation in the Sun, as was defined earlier in part 2. We now consider this limit case with just one more slot over 12 slots, which is the case of 13 slots at the surface of a central cavity over which are distributed 12 balls, leaving room for a 13th ball in a 13th slot. What will be found is that according to mathematical results which were found more than half a century ago, in this case the radial fraction defined in this geometry to correspond, as per part 2 of the Fivefold Sun, to the boundary of differential rotation in the case of the Sun, i.e. the center of one of the outer balls, is indeed located at 0.67 radius fraction of the photosphere, as indicated maybe from preliminary observations by helioseismology as reported earlier today. At solar maximum epoch, the question is whether such a limit is reached in the relative size of the central cavity, at which the configuration becomes relaxed. It was conjectured already in the time of Newton that there may be a 13th hard sphere of equal size that can kiss an equal central cavity, but it was proven wrong. In 1951 and 1953 by Schutte and van der Waerden, who proved that the radius of the cavity, which is necessary for 13th spheres to kiss its surface, is 1.09 times the size of the surrounding balls. So to have room for a free slot at the surface of the core cavity that we contemplate in the Fivefold Sun, we have to have a central cavity with a slightly larger radius instead of a slightly smaller radius compared to the outer balls. Indeed, it must be 9% larger. In this case of a ratio of 1.09, if you go through the geometry, you will arrive at the straightforward result that the radius fraction at which is located the center of a surrounding ball is at 0.67, etc. radius fraction of the circumscribing sphere's radius. So this is in line with what was seen in a few observations, helioseismological observations, that in the case of the Sun, during the specific phase of solar maximum, this location might be observed about 0.67 radius fraction. If this is the case, what is the consequence for the stability of the arrangement? As found by Schutte and van der Waerden, the arrangement is much less regular, in fact is not regular, compared to the icosahedral one with 12 slots. With a 13th slot we cannot have a polar alignment, axial alignment, and we cannot have equatorial symmetry. This is a degraded case. But the consequence, if we do not have a 13th actual ball in the 13th slot, is we have exactly enough free room to start a sequence, a kinematic sequence of translations of balls that would allow the meandering of a ball from a polar position to the opposite antipodal position as its end position. It is a possibility that warrants to be further investigated. Ladies and gentlemen, this is now the end of video 16. I thank you for your attention.